All right. I apparently have settings that are messed up for people can't type. We'll get that sorted in a minute, but I just want to get started here. Let's just. All right, off we go. Thanks for your patience, everyone. This is my first ever stream, so we'll see how this goes. Um, so today, my goal is to get you guys a full introduction into the Pact programming language. So we're gonna start with a bunch of important links, but I have a problem statement, and basically we are going to go through these 5 steps. We want to build a mining contract. So we're going to build a contract that can take in information with an oracle. It's going to be a really basic oracle, but it's going to be an oracle that pulls in how much Kadena has been mined, and then it's going to allow people to buy tokens that represent. It's basically going to be the Kadena Mining Club project, but simplified. So we're going to let people buy tokens that represent a portion of the total mining power, and then uh, the admin will be able to fund the wallet, a contract wallet that we'll be able to pull from. And then they're going to have the ability to stake or unstake the token so that it's mining or not mining. That means they can transfer it between Kadena accounts. They're going to be able to claim the rewards, and then they're going to keep a record of the claimed rewards. So we have an interface for this. It's not like we're not going to be building a website or anything, but essentially you'll have a dashboard. Um, let's see what I got here. So we'll be able to see how much Kadena has been mined. Um, what else? All of the tokens that the person owns. So they own a bunch of tokens. You'll be able to transfer the tokens. So you can uh, buy the tokens. You can transfer them if you owned this one, but I don't. So yeah, that'll be our general operation for today. I have some steps that I broke down here beforehand. I really didn't do a whole lot of prep beforehand because I wanted people to be able to experience uh, these issues sort of live. Oh hey, we got the chat working. Lovely. Good to see you, everybody. All right, cool. I just see that right in the corner there. I have a second monitor. I'm not staring at the wall or anything. So let's see what we got here. I hid these somehow. Yeah, it's white text. Okay. So how do we achieve each goal here? Let's get this thing out of here. Well, we achieve this goal by using a smart contract on the Kadena blockchain. And to do that, we're going to need a bunch of different resources. We're going to be operating on the test net, so this will be deployed live. You guys will be able to interact with this while we're programming it. Well, after I deploy it once, you'll be able to buy your own tokens, start staking, and start earning. So let's get started. We're gonna click on the. Oh, I need to share this link with you guys. I have this link so that you guys can all hop in on this. Um, okay, I just posted a Google Docs link. You can click that. It's view only, and then you can hop in there, and this will take you to the 5 resources. I might add more resources, but these are the top 5 that I use pretty much all the time. So we're going to open a chain waiver, which is the 4th link here, and we're going to create a new wallet. I guess I should probably hide this wallet because I don't want you guys to mess with me while I'm going here. Must be at least 10 characters long. Okay. Okay. So I'm going to move this off screen just for a moment so you guys don't see my 12-word passphrase. And we're starting straight from scratch. So this, you guys should be able to do everything that I'm doing live. Alright, I'm just going to type this in. Okay, so I've got a wallet created here. That's just, if you're not familiar with that, then it's just a simple 12-word phrase. All right. Hoo-yah, Ron. Hoo-yah. All right, so we've got our chain weaver here. This is going to be our client that we're using the whole time. This is the only thing that you're going to need to deploy on the blockchain. First step is going to be set this corner here to testnet, and then that will bring us to the next thing, which is our keys. So you've got 4 tabs over here. Accounts, which is going to be a list of all of your K addresses. Your keys, which are the base of those K addresses. These are public, so it's fine to share these. Your SIG builder, which we're not going to use today, but that's for more complex things. And then we've got contracts. So we'll have to add our K account here, and that will put it into our accounts tab. Now, first thing, it does not exist. So we need to make it exist. And on the testnet, the way to do that is to get free Kadena. Sadly, you can't do this on the main net, but you know, can't win them all. So we are going to create and fund the new account. Oh, sorry, this is link number 1 over here, if you want to follow along. So we'll create and fund a new account. We are going to paste the full K address down here in the account name, and then we're going to paste just the things without the K address, because that's our key from this page, remember. So we will click the little plus button there, and then we're going to click create and fund account. So we have a request key. This will tell us that a transaction is pending, and that'll take probably about a minute. And then we'll be able to get going with programming. For now, let's go over the next link on the docket here. We've got our balance checker, and this is a really nice website. It's probably the most reliable way to find out if you're broke or not. So I'll pull up this, and this is going to be our testnet address. If you want to look at mainnet, you just change this to api.chainweb, but we need the testnet there. I have a secondary account that we're going to end up using today, and that is going to be, don't worry about all this, this is just going to be something that simulates Kadena being mined. So it's going to update our contract every minute and tell it we've mined 0.3 KDA more every time. So, perfect. That's the account. I just needed to fund that earlier so that we wouldn't run into gas issues. Let's minimize that. There we go. So that's our balance checker. And then now we can check our balance of this account, which we just created. I guess you could check it on here too. Yep, there's our 20 KDA. We are good to go there. Perfect. We're already getting free Kadena. Nice. Alright, I'll try not to get too distracted by chat, but feel free to ask any questions. Hopefully I don't miss anything. But yeah, let's get going. So we've got our funded account. It's on chain 1. You can do a transfer to another chain. We are actually going to be using this transfer function later. That's going to be to fund the contract wallet. But let's get going. So we've got our contracts here. I'm going to pretty much skip like most of the actual documentation unless we run into something that I feel like needs further explanation. So first step, we'll click on contracts over here, and then they have like pre-made contracts. This is the Hello World contract. It's a lot more complicated than a regular Hello World thing, but no worries. We're just going to start from scratch. And yeah, for anybody that's new to programming, I'm going to try and make this as simple as possible, and I'm going to explain everything using an Excel spreadsheet. So if you're familiar with that, it should be not that hard, because a blockchain is basically just a really complicated Excel spreadsheet. It's got specific rules, and that's about it. So we've got our REPL here, which is like a little editor that you can start doing functions in, like 1 + 1. That'll tell us it's 2. And then you can do more complicated things in here, like adding lists together. So this is a list. Hello. And then, sorry, I'm a little shaky right now, from KMC. And then this should add our 2 lists together. So now we've got 2 items in this list. So that's like the REPL. I basically use this as a little bit of a sandbox. If something isn't working, or if I'm getting a silly error, then I go to here and try and figure it out. There's a much more robust way to use this, and that's for testing. But we're not going to get into that today because it's quite a lot to get into, and I just want us to stick with just the Chainweaver client here. So yeah, let's get started on the actual programming. So our first goal is going to be to allow buying a token that represents the share of the operation. So that's the first part is definitely going to be the most complex. And then as soon as we get the base built up, it's going to get a lot simpler. First step is to figure out the syntax of how to make a module. So let's go to the block explorer here. We're going to switch to code and go to define key set. Yeah, so this is how you give governance to... that was a really lazy contract. Okay, let's find a better one. I'm really just relying on pure luck right now. I probably should have had this prepared. There we go. Alright. So this is going to be how we define our key set. And this is how you give governance. So only we can update the module. So this is where we'll write our smart contract. We have module. What did I want to call this? I called it Pact intro KMC. And then governance. Perfect. So that is going to be the name of our contract. That's what people will see when they search for us. And then we'll paste this in here. I need to make this full screen, I think. This is pretty obnoxious. Okay. Ancient holder stuck at funding account. I'll go over that really quick because there's probably like one step that you're missing on funding the account there. Because I'll refresh this. This will make it go away. So ancient holder, you want to go to... Sorry, I'm moving pretty quickly. I didn't really think about it. You want to go to keys, get your address from here, create and fund a new account, and then paste your public key in this top box. There should be no K : here. And then get your plus there, and that adds your keys to the list. Now, if I added a bunch here, it would fund them all at once, but we don't need to do that. So I am going to add in the account name. You can name this whatever you want, but it's convention to do K : 53. And then we will click create and fund account. So I just did this 7 minutes ago, so it's going to make me wait 23 minutes. But hopefully that helped a little bit. Alright, let's get back to the actual programming. Alright, cool. He's got it. So, we have our module name here. We've got this, which we need to change. So the namespace is going to be... you can make more complex namespaces, but the free and user namespaces are available to anyone. You don't need to do anything special to be able to use them. So we define our namespace free, and you need to define that every single time you deploy your contract. That will be on every deploy of every contract that ever happened. There's more complicated ones, like we have define key set here, define namespace. This person's defining their own namespace, and then yeah, it looks like they learned how to define namespaces, but we won't get into that today. It's not, you don't need to deploy a contract. Yeah, I like VS host. It's a nice editor. Okay, so after you've declared your namespace, you need to define your key set, and this is going to be what you control the account with. So this person is Kadena Pepe token, so looks like somebody's building that. I might have just spoiled something. And then we will call this KMC Pact intro account. Okay, that's way too long. KMC account. And then we will do KMC account. And then it's saying over here in our little error box, no such key in message. So we're going to fix that by clicking the fix button. Super easy. We've got our KMC account here now, and then we'll click the little checkbox. And now, when we try and deploy, this will define the key set for the module. And what that means is that this governance thing here, which we're going to add in a little bit, will only let this key set update the contract. If we didn't define this, then I would deploy this and everybody would be able to modify it. Apparently something bad happened to Kadena Pepe, so that's disappointing. But yeah, we'll move on. So we've got our Pact intro KMC here, our module, and now I need to pull up my little sheet of wisdom here. All right. So step 1 is going to be to get our governance in line. So I actually have our contract here as the 5th link, and this makes it, I mean, it's a lot of code here, but being able to reference something that is functioning live on the blockchain is super nice. So I'm just going to do a Control F for AP governance. Well, if I can do it on this page, maybe not. All right, let's open another Chainweaver then. Cool. Okay. So we're going to go to our Module Explorer here. This is actually a really nice feature of Chainweaver. So you can search for all deployed contracts. So I'm going to set this to mainnet. That way I can search for my contract that exists on the mainnet. And then we'll just click View on that. That'll bring us to the Kadena Mining Club. Oh, thanks for the reminder, Hank. For anybody that is participating in the Kadena Mining Club community event for this class, I'm going to be giving out 3 keywords, and that'll be throughout. I'm going to do it in the first 40 minutes or so you're not stuck here if you don't want to be. And then you'll just type in those 3 keywords for into a Google Doc, and that's how you'll get your credit. So the first keyword is KMC, all caps. It looks like this. That is the keyword for anybody that's watching. All right. So we have our contract up here. Oh, I think I never shrank my little box down. I wanted to make this a lot smaller. Yeah, this will be a lot less intrusive. Did that get smaller? Okay, I think it did. Okay. Right, so now we're going to open our contract, and this is how we're going to look at all the code. So we have our governance, and we're basically going to copy and paste this governance, and then I'll explain it. So we have our governance capability here. We'll copy that into our contract. And then we need our admin key set, which is defined here, but it needs to be inside the module. You can see it's outside of these little parentheses, so it's not inside the module. So we'll define it with a constant, which is another type of variable, which is just a string in this case. So we'll do const admin key set. There we go. So we'll copy that. Alright, and then we just need to make sure this is called KMC ACC. Okay, so now we have the absolute minimum thing that we would need to deploy this contract. So let's try it out. So we have all of our KDA is on chain 1, so we'll choose testnet chain 1. This raw command here is just telling us what we're submitting, and in this case it's all of the code that we see on the left. Our sender will be the only account that we have. Our gas limit, I'll show you what will happen if we don't change that. So we'll go to, that's the end of configuration. The only thing you really need to change here is how much you want to spend, and then how much you think it's going to use in terms of a complex transaction. So Go to unrestricted signing keys, click your little checkbox here, and leave coin.gas blank. Can I add comments? Yeah, so I'll show you that in a moment. Yeah, so we're getting a gas error. Gas limit exceeded. It's saying it's going to cost 60,000. That is always somewhat inaccurate, but we only have 600 right here. And basically, to deploy a contract, you need to spend about 6,500 gas, and that number, to keep it simple, if we do 65,000 is what I meant, gas. We'll do 65,000 times this, and that's what gets you how much Kadena it costs. So this number right here, we're going to spend 6 10,000ths of a Kadena to deploy this contract. A lot cheaper than Ethereum. All right, so we've got our raw response here, and that is saying that it's loaded the module, and our hash is this. We don't really need to pay attention to that right now, but that means that it's a success. So our module is functioning, and this will start appearing on the blockchain now. If we go back to our screen at the top here, we go to testnet, you'll see that our contract, which is called Pact Intro KMC, it's kind of laggy for some reason. Probably because I have way too much code in this editor. How much code is in here? Yeah, 1,500 lines. Okay. So it's not here, and that's because it's not done deploying. So we'll just give it a minute there. Stay hydrated, folks. This usually takes about a minute. I did set the gas to like the absolute cheapest that is allowed. So if somebody else is deploying something at the same time as me, then it won't, like, I'll be pushed to second in line. So I won't, I'll speed that up in the future. There we go. Successful server result. So we can check over here. We'll click the refresh, and now we should see our contract. So we can go here, and it tells us what is in the contract. I'm just going to leave this up so that we can continue to like copy and paste useful little bits. But yeah, that's our first step there. Let me actually pull up the Pact certification. This is what I wanted. Alright, this is what we're going to go over today. Probably should have started with this, you know. There we go. So we're going to be able to do everything here after this session today. I hope this session is like an hour and a half long. So right now we finished module governance. So I want to make that green. Sure, we'll just do this. We've got module governance set. So now only this account can update. Only this account can update this module. If somebody else tries to deploy and they do a different key set here, it will just deny it. I'll show that once I start creating test accounts, like so we can buy the tokens that we're going to create. So we've got the module governance. What is next? Okay, contract initialization. Let's do that. Okay, one more thing. We've got our governance. Now we're going to start actually programming the logic. Sorry. There we go. Not a lot of space to work with on this. Okay. So we're going to get a token that represents the share of the operation. So let's build the token. What does that mean? What does it mean to build the token? Get a new spreadsheet here so we can have some nice small boxes and whatnot. So to build a token, we need to define a table that's going to exist. So let's call this table token. And then in that table, we're going to need a couple different attributes. So we've got the table name, token, and then we've got attributes. I think this is the best way to do this visually. Sure. Okay, so our first attribute is going to be the owner. That's going to look like a K address. So K, XXX, 3/4, whatever. Next attribute is going to be the ID of the token. I'm just going to do them sequentially, so it'll be like 1, 2, 3, and so on. What else do we need? We need an owner, we need an ID, we need a variable to check if it is staked or not, so we'll do staked. And that will just be a true false. What else? Well, let's go with that for now. So we've got def schema. This is how you define a table, the structure of a table in Pact. So we've got define, this means define, schema, but the actual syntax is called def schema. And we'll name this token. And then you can add documentation. Okay. And then finish that off there. Now we can add our 3 different attributes. So we've got owner, which is a string. We've got ID, which is also a string. You'd think it would be a number, but it's easier to do a string, and I'll show you why eventually. Yeah, so here's our commenting. So to comment something, like this won't mess up our code. You do semicolon, hello, Ron. Or who asked that question? That was Ron, right? Yep. And then staked, that's going to be a boolean. Okay. So we've got those 3 in there. And that is going to be the structure of our table. Now to actually create or to set the table, we do define table. So def table. And we'll call that token table. Sure. My hope is by doing this without like copying and pasting everything, is that I'll run into errors and then we can work through them together. And that way it can be more of a learning experience instead of just copying and pasting what some YouTuber says, because I don't like that style. So we'll do def table, token table, and then we'll do, I think this is the syntax, right? Yeah, perfect. See, always good to reference something before you make a stupid syntax mistake. This is a bit easier in an actual editor, but this is fine. So token, and that is our table created. So it's pretty simple. What we've done is we've created this token, a table for this token, and then this is the structure that it must have. So if we're going to add anything to this, it will always have an owner, always have an ID, and it will always have this variable that represents whether or not it's staked. Let's see what else we have here. I think that's it for now. Okay. So now that we have that, we need people to be able to buy this token. Actually, one final step. We need to create the table. And note that this is outside of our module. You can see this little highlight here. So this is outside of the module. That means it's happening, like, it's a transaction that's sent almost separately from defining your module. So we'll create the table token table. And now, when we submit this to the blockchain, I won't actually do it. I'll just show you, so we don't have to sit here and wait. Table created. So if that line wasn't there, this would just say write succeeded or loaded module or something. Yeah. So we'll put that back. Cool. How are we doing? All right. So we've got our table. Now let's make it so people can buy it. Um, we're going to use uh, we're going to use a coin contract that is going to let people spend Kadena from the testnet to buy this. So let's do a function defun. Don't worry, carnivore. So I'm gonna have to do each one of these things like a dozen times, and each time it should get a little bit more solid. So this one is define function. So define fun function. Defun. Um, what do we buy token, and then we'll do defun buy token. And the syntax for this is now we need. This is our function definition. This is the name of the function. So when people see it, they're going to see like what would they? They would see place NFT offer. This is something that we have on our website. So they'll see that. So we need, what do we need here? We need to know who is buying the account, or who is buying the token. So we're going to call that account, and then that is going to be of type string. Oh, I guess I should explain these things. So a string is just like a bunch of letters. So it looks like this. This is a string, where it's just a sentence, and you define a string by putting it in between quotation marks. So you can see I just made one of these, and now the editor thinks that this entire thing is a string. Ron, so events you see on the Explorer are function names. Events are actually something different. I can show you emit event. So this is on our contract, Kadena Mining Club. So we have our place NFT offer. Ignore everything that's in here. We'll just get rid of that. And you've got emit event. So when when somebody places an NFT offer, we can search for this, and then go to events, and then paste that in there, and we should get a list of every time that somebody has ever placed an NFT offer. So these are not function names, but you can also search for function names by doing, in our case, it's going to be Kadena Mining Club dot place NFT. That's probably good enough. And this will say every time somebody has ever called it. So all of these are people using that function. Some people are failing. I assume it's because they don't have a high enough balance. But there's no way to know without checking the balance here. Let's do that. I don't know why I'm checking this right now, but I was curious. Yeah, he's only got 5 KDA, so he can't place a transaction of 210. This is the general troubleshooting that I end up doing. Alright, so we'll go back to our function here. So we need to know a bunch of things here. So account, which is the person who's buying it, how many they want. So amount is going to be an integer, which is just it's just a number like 1, 2, 3, 4, 5. It's not specifically not anything that ends in a decimal place. So an integer is always a whole number. And a bool is just a boolean that means it'll be true or false, like that. And let me fix that there. Okay. So we need to know that. We need to know how many they want to buy, and that should be good there. Okay, so we're going to work through quite a lot on this this token. I'll write a bit of documentation here. Let's make an S on this. Okay, so allows the user to buy many tokens. Cool. So, what's the first thing we need to do? Let's think here. There's actually quite a bit. Maybe I should have started with this, but you know what? We're doing it. We need to get Kadena from one person's wallet to another. So basically, we want to collect the Kadena from other people. And to do that, we add a use statement up here. And use means that it's going to pull from another contract. So in this case, it's going to pull from the actual Kadena coin contract. So this is what all of your KDA exists on. If you have KDA, this contract controls it. Among the 20 chains, but you get the idea. So this is called coin. It's not called KDA, it's just called coin. If we had a KMC token, it would be called, we might call it KMC coin, or you have CADX, which is called, I think they just call it KDX. But anyway, we're going to use this coin, and it's pretty simple to do a transfer. So we will do coin.transfer, and then you need the from address, which is going to be account. You need the to address, which we need to define. I know I have a test account. Let's use this one. Contract wallet. Okay, so we have our contract wallet. This is just one of my accounts that I know exists. So we'll use that for our contract. And that's where people are going to send all their KDA to when they're buying something. So we'll say coin.transfer from the account that's buying to the contract wallet. And then how much? So how much are they going to spend? They're going to do the price of the token times the amount. This isn't the actual syntax that we're going to use. I'm just working through this. So we're going to define the price elsewhere. Define. We're just going to create these things up here are just static. They don't change. They're called constants. So def const price, and then this is going to be a decimal. So we'll say a price of 0.5 KDA. And that is the name of the thing. So let's do price. So we have price, and then the actual format for this, I can show you over here in the REPL. You see earlier I did like a plus in the beginning. So if we try and do like 5 times 10, like a normal human would, we have to do something else. We have to do the multiplication symbol first, and then 5, and then 10. And that will give us 50. So we'll use that same format over here. So times price, and then amount. So now when somebody buys, it will look like this. They'll have the price, which is 0.5, and then times the amount, which can be anything. So let's just say 2, for example, and that means they're going to be spending 1 KDA for 2 tokens. So it's that simple to transfer coins from one place to another. We'll add a contract wallet later, and that will make it a bit more robust so that people can spend money in the contract, and then we can withdraw money from the contract, and that's also where all of the funds will go when we're mining. Alright, so they've paid us for the token, but we haven't given them anything. So to give somebody something, we need to, give them a token, we need to add to this table that we've created. So we have this token table, and we need to insert a new token. So insert is the thing that we call to update a table. Insert token table, and then I'm going to do it manually for now, and then we'll make it a bit more robust later. So insert token table 1. That's going to be the key. So this token is going to be called 1. And then we'll just use this formatting that I'm used to. We have our owner. And then our owner is going to be the account that is passed in. So that is going from here to here. This is the same thing. So I'll give an example. Purchaser up here. All right, example purchaser. That was a lot. There we go. And then the amount, we'll just say 2. Okay, so the owner, and then what do we have? We have the ID, which is next on the list, so we'll add the ID, which is going to be 1. We make these things share the same, like the name of the token and the ID, so that we can easily look it up, and I'll show that later. Oh, thank you, keys. I didn't close these. So this is the proper formatting for a function. So you have the defun buy tokens, and then you have this is where you put all of the things that you might add in here. So you need to close these, and then you need to close that as well. So I'll close the insert while I'm at it, just so I don't lose that. And then we will make staked. So staked is going to be false because they just purchased it, so they didn't stake their token yet. So, okay, that should be good there. Let's deploy this. So we click the deploy button, and then now you can see there's a bit more in this raw command. We will do testnet chain ID, deploy with this account. We're going to change this to a bit more expensive there, just so it goes faster. And then 65,000 is good for now, but as this gets bigger, we'll have to do more. So like my contract, the Kadena Mining Club one takes about 90,000 gas. Makes it a tiny amount more expensive, but it's not really relevant. Click your signing keys, leave the coin.gas blank, and go to the next page. Alright, good. I messed something up. I probably forgot a brace over here. Yes. So it said end of command was not correct. And that's how I knew that. And then, can I multiply a decimal with an integer? Yes, I can. Yeah, you can multiply a decimal by an integer. It will result in a decimal, so like I wouldn't be able to pass it into here, but yeah, hopefully that helps. And then we're getting another error up here, and it's saying module coin not found. That's not really relevant because this doesn't search the blockchain until it's deployed. So you'll see we won't get an error. You'll always see that error forever when you're using this IDE, which is a little annoying, but it just means you've succeeded. So table created. All right. Looking good. So now we'll wait for that to go. Any questions so far? I guess this isn't the most friendly thing in the world for new programmers, but hopefully as things get repeated more and more, this helps. Because we're going to be creating more tables, more functions, more schemas, and that's like a large portion, or pretty much all of what you need to do. Ancient Holder asks, so if the contract is written incorrectly and can't be deployed due to a syntax error, you don't waste gas. That is correct. So whenever this is done, I'll show you what happens if I like have a bad, if I try and deploy with some bad syntax. You can waste gas, but this transaction result, you saw how it said like it was going to succeed already, and that's like it knew that it was going to succeed because it's using a result and feeding that to you before the miners actually even know what's being fed. It's called the local result, and that just makes it so you know what's going to happen before you spend money. If you did click submit, even though you were getting an error, you would then be charged the full amount of the gas that you allowed. So it would be a full 65,000 times that tiny decimal. It's not like devastating if it happens, but it can add up. All right, so we've got our successful server result. We've created our table, and that means that the rest of our code is here. So we should see on the Module Explorer, Pact intro. Oh, let's do another word for the KMC community event. So it's going to be the number 4, just like that, number 4. So first one was KMC, and the second one is the number 4. All right, now let's view our contract here. So we've got our function buy tokens. So we're using a module. We're using the coin module, which I showed you over here. Oh yeah, you can actually read the documentation. So coin represents the Kadena coin contract. This one's a bit more complicated because it has gas support, but all coin contracts are essentially the same. Some of them have some special features, but they all need to have the same base to them. So we've got our use module, we've got our one singular function that we've created, and then our governance capability. And the governance capability is just what we defined earlier, where only we can update it. So let's click call on this function. Let's do this in order actually. What's my account? I'll save it over here somewhere. Okay, cool. So let's buy our token. To add an account in here, we need to add it, like copy this and then surround it with strings. So that's what that looks like, and then we're just gonna buy one. And then we move to configuration. This is now the raw command. So all we're doing is we're calling the module. We are calling the function and then passing it these two things. So the account and the amount of tokens that we're going to buy. So we're going to buy it with this account that we created. And we do not need this much gas. This is going to be much, much cheaper because all we're doing is a tiny little write to a database. Sorry, I need some water. Alright. Yeah, if you're looking at this screen, really the only thing you need to pay attention to is that you've got your account selected, your gas price. If you set this to 1, just so you're aware, you're going to be spending 65,000 Kadena. So, like, don't ever do that. You always want to have at least 5 zeros. Yes, Ron, this is exactly how you would manually interact with contracts. This, like, anybody can do this with, you guys can actually go onto the blockchain right now and buy tokens. You'd be giving me testnet money, but you can do that. So let's see here. That looks good. So we'll just set this to 5,000 right now. Or actually, let's see how expensive this is. Let's set it to 100. You don't need to open advanced. Well, we will later, but not right now. And then we will go to unrestricted signing keys and then preview. So what's going to happen here? It's going to tell us we have a failure, and this is expected. So this is what's called a capability. We already saw one. This is in our thing here. So we have capabilities. Excuse me. These are guarded contracts, guarded functions with capability. So the coin contract has a capability that you need to add. We're trying to send KDA from this account to the contract account, and we're going to send this much. So we just copy this thing here, everything after the semicolon, and we click the plus button, and then paste it here. So that's just there. And then finally, we're going to fill in this coin.gas field and apply it to both. So this means that we're going to pay for the gas. We are going to pay for the coin transfer, which is 0.5 KDA, and then we're going to go back to preview. There we go. This is the gas that I wanted to show you. So it costs more than 100 gas to insert something. So let's set it to 300 and see if that's enough. Nope, not yet. 400? It shouldn't be much more than that. Yeah, I think we're looking at like 500. Alright, 1,000 it is. There we go. Alright, so this says write succeeded. So we have we will have purchased a token at this point. I'm not going to do that because I want to make this a bit more robust. As soon as I do this, this is the only thing, like we're only going to be able to create one token, and that's useless. So I made this like the most generic possible thing, or the least generic possible thing. So we're going to make this a bit more robust. To do that, we are going to create a counter, and I will open up my contract again. There we go. So onGet count. So we have our counter. Let's just get all those. These are going to be utility functions. Okay, so we have get count, and this is expecting a table called counts table. So we will create a new schema called counts schema. Oops. Def schema, count schema. Ron asks, this is for a fungible token, right? Not an NFT. This is basically what people would call a butter NFT instead of a marmalade one. That's literally just an entry on a spreadsheet, and the owner changes based on who wants it. So this is an NFT with no art and no distinguishability. So it's really just an entry on a table, on a spreadsheet. All right, let's continue. Count schema. Count integer. Or maybe this is a string. I think it's an integer. Sure. Should have just copied and pasted this from the start. Perfect. Now, when we call get count, this has a schema. We will add a table. Cool. That's the syntax for adding a table, and then we need to create a table. So if we try and create a table again, this one will give us an error. So I'll show you. Set this back to 65,000, otherwise it won't deploy. Cannot resolve admin. What did I mess up? Ah, right. I did not make a capability here. Sure, we'll do that. Get rid of these two. Okay. So we have our admin capability. I'll explain that in just a moment. And then our account card capability. Sorry for the disorganization here. This is what happens when things are done more on the fly. But I think it's a good time to go over another bit of capability over here. So we have this capability, which I've defined as the admin capability. So only the admin can do something here. So what it's doing is it's enforcing this key set. This is a bit of a double protection, but it's enforcing the key set that I have up here. So this thing that we created back in the beginning, it's this guy. Only he can call these functions. And then he can always do something that is called private, which we'll get to later. And then he is also going to be verified on the coin account. So this is two checks here that is making sure that the admin address is going to be accurate. I think I need to create the admin address as well. This is not the easiest editor to work with. Admin address, and that's going to be our K53 account. Perfect. Now we're checking it in two different ways. And then we also have the account guard, which this is a more generic one, where if I'm the owner of a token, and I only want the owner of the token to be able to stake it or unstake it, which makes sense, I would add this. So that's what this line right here is. It's with capability admin. So the admin is the only one that can set the count of something. And then, cool, that looks good there. We have the counts table, count schema, and get count. Okay. So def const, I think we do counts. My god, this is a lot of scrolling. Okay. Def const count. And then this is just going to be called count. Token count. Cool. Alright. So, now, this just made this a lot more robust. We're going to call a function from within another function now. So, to do that, this was originally just 1. So now, when we do this, we're going to say get count, and then the key is going to be the count. I guess I should do like token count. Okay, so this is named token count. Token count. Cool. Good. And then that will give us an integer, which is not what we want. And now we can go to the documentation. The thing we've all been waiting for, reading the documentation. Int to string. See, I've done this before. There it is. Alright, so we're going to use this int to str, which is converting a number into a string. So if we start with 1, it will convert it into 1. And it's pretty simple. We're going to do it in base 10. Sorry for the dog there. We're going to do it in base 10. So to do that, we do int to str 10. And then that will set this token table to always count up by 1, or to always use the next count. Alright, and then we need a function called, we need to make this go up by 1. Let's use this again. So now these will always be the same. And then we need to increase the count. So say it's at 1. We've minted token 1 with ID 1. Sorry about the dog. And then we are going to do increase count. See, this is what we're doing on my contract as well. On increase count. get count, set count. Cool. So we'll call increase count. Now we're going to call another function from here. Increase count, token count. Cool. I renamed this to just by token because we're only doing one at a time right now. Increase count, token count. And from there, now we've got a pretty functional thing here. The only thing that's missing is you might have noticed that I set this token count to just be a string called token count, which doesn't really make sense. But that is where this piece comes in. Contract initialization. So to initialize a contract, we create a special function. You can call it anything you want, but I always call it initialize. And it takes no parameters, so it's empty. Here's our 2 parameters in the other one. This one's empty. And then we close the function. And now we just insert into our counts table. Insert into our counts table the token count. So we're going to call the token count is essentially what we're doing is like we're adding the 1 from earlier. But in this case, we're calling it, instead of we're calling it 1, we're calling it token count. Insert counts table token count. And then what is the thing that we need to pass in there? We need to pass in a very first value. What's the syntax on that? Just this, okay. Count equals 1. So this is the syntax on that. We're going to start with token 1 so that the first one that's minted is 1. Otherwise, it would be 0, and you don't want that. So now we're initializing the counts table. We're starting this right here at 1. This is going to be 1, and then it's going to go up and up. Every time that we buy 1, it will go up by 1. So let's deploy and test this thing out. Cannot resolve private. Right, I added this right here. This is actually a really important capability. This is the next thing here, so private functions. I'll copy this from over here. App private. Alright. So these have a really interesting capabilities are a very interesting part of Pact. This capability, it always returns true. So in these cases up here, if a certain condition is not met, then the function will fail and then nothing will happen on the blockchain. But with private functions, you have, or with this private function, you have true, which means that it's always going to pass, which might seem a little confusing. But what's actually happening is I can choose where I want that capability. So now, when I try and call this increase count function, the private capability will make it so that only another function can call it. So to make that happen, we add a with capability here. This is the really powerful part of Pact here. It makes programming with permissions really, really simple. With capability, private, and then we just wrap that around here. So we have our syntax with capability. We have our capability name, which is down here. And then we have our function or whatever is going to happen that requires the private capability. So we're granting the capability here, which means that this function will be able to call this one. Nobody else can increase that. I can never increase it as the admin. It just always goes up when this function is called. That should be good then. So we'll choose chain 1, this. Database exception. Alright. So this means that we're trying to create a table twice. And that would make sense because we didn't change this create table from earlier. So we've already created the token table. Now we can just change this to counts table. These are the errors I was hoping for. Things that you'll encounter very commonly. There we go, table created. That means that everything above this line down here has succeeded. And we don't have to sit here and stare at this waiting for response thing. We can go code some stuff and then just put this in here. And whenever this is done, this will give us an actual response. So let me close out of all this stuff. Cool. So now we're going to actually like start buying our token, and then we'll move on to, they'll have a unique token ID, so that'll be good. We will make them buy multiple at once. We've added the account card, but not to specific functions, so we'll get there. And this one we're done with, so we can move on to the next column for now. Cool. It seems like we have a lot to do, but we do not. This is these are all fairly simple, and they all use the same base, so I don't need to like constantly explain everything. Did I mess up that function call? Probably. I guess this doesn't give me a live feed down there. Alright, well we can just check that in the Module Explorer. Yep, so all of our code is there. If we leave this and come back, we have our new functions. You know, there's actually something I forgot to do. I'm adding the namespace free again, lowercase, because I clicked open and that deletes it. I'll show you that. It's just a quirk of the editor. And we actually never called our initialize function. Hey Tiptoe, good to see you. So we need to call our initialize function, and that will insert our count, our token count there. So we'll have to deploy again. Alright. Looking good. We can just keep reloading this thing. After this, we will mint a few NFTs, and then we will add... We'll add the ability to unstake and stake, which is going to pretty much cover a lot of like the record keeping. And then we will add the math functions that will determine how much somebody has earned. And then finally, we will add the oracle. So the oracle is what I have already programmed before, just to save ourselves some headache there. And I'll share that oracle code as well. I think it's been an hour or so. So the final word for all of our KMC viewers, thanks for your patience. So let me just check, make sure I'm not getting this wrong so I don't screw you over on the forum. Yep, you might have already guessed it, but the code is life. So KMC for life. Those are your three words. There you go. And Ancient Holder has a question. Every time you update the smart contract with new lines of code, you need to pay gas. That is correct. It's efficient to code the whole stuff and then deploy it in one go. Yeah, all caps on all three. I copied and pasted this from NuGet. Testnet, it doesn't matter. And then also, normally you wouldn't code everything live on the blockchain. This is just really helpful for a live demo. So, excuse me. So you would do this in an editor where it's free and you don't have to wait for things to deploy. Excuse me. Alright, what do we got? So this should have deployed with the initialize, right? Let's find out. Let's call get count. We'll pass in token count. And this should return a result of 1. I had a cold this weekend and I'm finally getting over it. So what we've done here is we've called one of our functions. All we've done is passed it this token count. So we've been calling get count. We pass in the key, not that key. And then we check the preview. This is the expected result if we submitted it. So we don't need to submit it. We just wanted to check if this was functional. So now we can buy our token. Let's copy this guy. We've got our account. We'll surround it with quotation marks. Oops. And then we'll buy 1. I'll try and speed this up a little bit here. So we'll copy our capability here, and then paste it in. Set our signing keys for both, and now we have a write succeeded. So let's check the balances on these two. I suppose this didn't become very useful. Balance. There we go. So let's check the balance on this right now. api.testnet.chainweb. Oh, and that was the final 3 codes. There's no more codes for anybody that wants to move on. Thanks for joining, though, if you do choose to leave. Alright, so this is our account that we're paying money to. It's got 3.79 KDA. Whenever this transaction goes through, this guy should update to 4.2. So that means we've bought 1 KDA from this guy. Whenever that happens. Let's figure out what we're going to do next. Let's make the Oracle function next. There we go, write succeeded. Close that. Close that. There you go, 4.3 KDA. So now, I don't have any way to determine what tokens this guy owns, so that's going to be pretty useless for him. He just bought something and has no way to know what he bought or like how many he has. So let's find out. So let's add another function called defun. The function name will be get tokens owned, and then we're just going to pass in account by that will be like who owns the token. So we'll pass in this address. Thankfully I saved it. Yep. Get tokens owned. So select. This is another function that we can go over here for to the documentation. Select. Alright. So this lets you select from a table. So we'll do select, and then we choose the table name, which is this people here. Our table name is going to be token table. And then what do we want to select? Let's just select only the ID and the status if it's staked or not. So to do that, we follow the syntax over there. ID and staked. So now those two are going to be together. And then we'll say what is true. So in this case, we want the owner, where owner is equal to account. All right. So that's how you use a select statement. This error should go away. It just takes a while, I think. I don't like that comma. All right, what did I do wrong? I like this one. Let's figure out what I did wrong. Maybe it doesn't like this. Alright, let's just select that. It was probably the comma. Okay, yep, that was it. We'll do this. So now we have a functional it's a functional thing here that will tell us the ID and whether or not the miner or the token is staked for this account. So that is how to use the select statement, and it gets a lot more complicated. If we do like and, you can have multiple conditions. Let's see. I know I have one in here with 3. Yeah. So we've got 3 conditions. This one is pretty miserable, but it works. So you say like where the price does not equal 0, where the previous owner is equivalent to the person that you're passing in, and where it's not this type of NFT. So those are 3. That's how you do 3 selects. This is where it's really useful to have a contract where things are functional, because this is the entire documentation for select. Like, I really wish that there was more examples, more specific, but eventually, figure this out. Blockchain is basically a database, Ron. Yeah. A blockchain is essentially just one giant database with specific permissions on everything. You can literally just look at it as that. And it has the same ability where you can't ever delete a row. You can overwrite it, but you can't delete it. So you have like a default value for things that you want to delete. So we've got the tokens that this guy owns. Let's deploy that, and then while it's deployed, we will do a bit more. Set this back to 65,000 so we can deploy. I'm still trying to add the initialize thing there, so we'll comment that out. You get very used to clicking these things. Alright, so we'll just click done there, and then that should eventually finish. What's next? A function that acts as an oracle. Cool, let's do that. Insert KDA mind. This is what we're going to call this. So we're going to insert the... It's basically pulling from a pool. So if you mine 1,000 KDA and your pool shows you that, you'll have 500, or you'll have 1,000 there, and then the next day you have another 1,000. So this is basically just keeping track of what that would be. So defund insert KDA mind, and we'll do KDA mind decimal. This just means decimal is like 1.5 or 1.001 or something like that. And then we have a really simple one for ours, but it can get a lot more complicated. Insert KDA mind. Yeah. Yeah, so we can copy this. So what's going on with this code here? We have our private function, which means this can only be called, or this can call the increase count function. If it didn't have that private thing, it wouldn't be able to increase the count. We have a new capability here. So the account guard, And I have this as the Discord address. Let's rename that to the Oracle address. And let's create that up top here. Def const Oracle address. And then it's a little unfortunate. Alright, I'm going to have to pull this off to the side. Oh, there it is. Oracle address. I've created an Oracle for us, so we don't have to worry about that. It's very simple. It's like 30 lines of code or something. So insert KDA mind. Here we go. So we've got our Oracle address. Now, when this function is tried to, like we try to call this, no address except for this 4AA address that I just added can call this. We'll have to add a update count here and a KDA mind table. So let's do that really quick. Def const mind update count, and this is going to be mind update count. And we have to initialize that. So anytime you do, you create a new constant that's going to go in a table. See, this is why we created the counts table. So now we can use it for multiple purposes. Is that really the... Yeah, it worked. Okay. We'll comment this out because we don't need to insert it twice. Count. And 1, I guess. Yeah, 1. Alright, we need to call initialize again. Whoa. My bad. Couldn't see the bottom there. I think I just changed the font of everything, unfortunately. There we go. Sorry, I'm just scrolling all over the place. Okay, so we'll delete this. Good. So we're doing the same thing that we did earlier with the token table, where we're doing int to string, base 10, and then we are just getting the update count, so it will be 1. And then every time that that function is called, it'll go up by 1. So we might mine... I have it set to do... Don't scroll up, yep. I have it set to multiply whatever, so it'll be 0.3 KDA every minute. 0.03 KDA every minute. So we'll do that. Insert KDA mind. Increase count. Good. And then what's next? Okay, I think that's it. We can check our deploy here. So this is our new function, get tokens owned. We can check that over here. So he owns this token, and it is not staked, so that is all fine and dandy. We actually need to add another variable to this token structure. So to do that, we are going to do... we're just going to add a new one, and it won't break anything. So what are we going to call it? Mind index integer. What time are we at? 5:26. Okay. Yeah, we'll probably have this functioning in about 30 minutes. Okay. Yeah. Slayer says, I love watching and hearing the degree of trial and error. Yeah, you're literally watching me think this through live, so this is not pre-planned. I think it's helpful to see that. It's not like just this, oh, well, I have all the answers to everything. I have to like actually think about what's going to happen next. So I forgot that this needs to happen here. So we need to have the mind index. This is going to be like if we've mined 10 KDA at index 1 and you've staked it. Now, when you, let's say another 30 indexes go by and we've mined 50 KDA, you have to take the difference between those two. So 50 minus 10 is 40, and that's like your proportion. Hopefully when I actually make the function, it's a bit more clear. What else do we got? Mind index. Okay. So now that we're doing the mind index here, mind index, we'll add this here just so that it's like populated. Mind index is going to be 1. What's wrong with that? 1. Cool. So let's make it so you can stake then. We have our function. This is our oracle. Once we deploy, we can start using that code that I wrote that will just like constantly call it every minute. So let's add the stake thing here. Defun stake, and then we need the account that owns the token. We need the token ID. And that's going to be a string. And I think that's it. Let's try that. If we run into anything, we'll figure it out. Defund stake account string token ID. Alright, so what do we need to do here? We need to update this mind index and the staked to whatever the current value is. Well, stake is obviously going to turn on. So let's do that. Instead of insert, which is our red function here, we're going to do update. So insert creates a new key. This is our key here. So update changes the values within the key. So update token table and then token ID. So this is going to be like 1, 2, 3, 4 in the parentheses like that, or in the quotations like that. And then we'll close that and add these little bracket things. So this is the general format for update and insert. So we have the staked variable. We'll set that to true because we are staking it. And then the mind index to whatever the current count is, actually. So we need to get this thing. And add a parenthesis, otherwise everything's a string. Okay. Get count, KDA mind update count. That looks good. We can check what like my function is doing over here on turn on miner. So ours is more complicated because it claims for you. It makes sure certain things are not wrong. But we're updating the staked to true. We are updating the mind index. We're making sure that it's not for sale on here. We'll get to what an enforce statement does soon. Okay, yep, that looks good. And then we need to unstake it because, like, that would suck to permanently not be able to claim anything. Account string, token ID string. And then we'll just copy and paste this. False. Mind index. We can set that. It can be useful to set that if you want to track how much somebody hasn't mined while it was off. So now there's one thing that we're missing here. This is really important. From this list that we have here. What else? Enforcing guards. This one. So this one is especially important because right now anybody can come in here and just like stake this token for you or unstake it for you. And that's not what we want. So we've added this capability earlier called account guard. And we've used it a few times now. But we haven't used it to like identify something as yours. So we have the account guard account, and just for my sanity, I like to indent that. So we surround all of the code that we want to use, or we want to call in here. Now, if I try and call this with an account that is not the owner of this token, then it's not going to work. So I actually need to add another capability called owner. Minor owner? There we go. So we'll just call that owner. Alright, now we can learn how to use a let function and an enforce function. Perfect. So token owner. And now we will just do with read ID. No, token table ID. This is a new function that we're going to be using here. So with read token table ID, and then we want the owner from that. So we'll do owner. Owner. This looks really odd, but it's right. Okay. That looks a bit better. So we are getting the token owner from this table with this. So if we go over to here, we actually have read. With read. Here's your with read. So with read accounts, this is the table that you're reading from, the ID that you want to read. So in our case, it's going to be like 1, 2, whatever. And then we set it, we want the owner, so we set the owner equal to owner. And then owner. That should work. Right? Not quite. There we go. Okay. Now we have a functional thing here. Until I break it. There we go. So we have our token owner. We want the token owner to equal the account that's coming in. And then we want the we want this person to only be able to use or only to be able to call it if they are the actual person who is calling the function. So compose capability is another bit of this little chart here. It just means that within the owner capability, I want the account guard to be in there as well. So I don't need to do like 2 with capabilities on the stake function. I just need to do with capability owner account. So now when I call that, only the person who calls that, or who owns the token, should be able to call it. And I don't think I actually explained what let does. So if you're familiar with programming at all, you'll notice that I haven't really defined any variables except for the constants. The let function lets you define a variable. So let's see here. This is some really bizarre formatting. I'm gonna fix this. All right. So yeah, we want this. Okay, this makes a bit more sense to me. I was just struggling with how poorly that was written. If I can type. All right. So this is written a bit better now. I've got a function called getOwner, and I pass in just the ID, which is 1, 2, 3, and then it returns owner. So this is the format, and then what I'm doing at the end is I'm returning this. So I can set the type to string if I want to. So now this function will be guaranteed to return a string. If it tries to return something else, it will break. So now owner is being returned. So that's what this is calling right here. So now get owner ID returns like k xxx whatever. And then that sets the token owner to be there and usable by this let function. The syntax is really weird. I don't know why these two are here. I guess you can have more. So if I want to do get or staked, then I would do get staked if I had a function that did that. But we don't. And then last thing to analyze here is the enforce statement. This is something else on here. Enforcing. This is a really important function because if this condition is not met, it will just fail. It's a really important part of Pact, and it's sort of like an if statement, but instead of like if I write an if statement here, the function will continue and it won't cause it to return a bad value, and then people can just like bypass it. So with enforce, it guarantees that you are going to stop the transaction in its entirety, and anything that happened before it won't happen. So we're enforcing these two values are equal. So the token owner, which I just pulled from this, and the account that's I passed in earlier. Enforce these two, and then this is like the error message that you'll get. Account is not the owner of this NFT. So let's give it a shot. I know we did quite a lot there. We will just deploy and see what kind of errors we get. Cannot resolve KDA mine table. I did not make that. So we have to create a schema. Let's do we have to create a table. All right, good. And then we need to create the table down here. All right, we're creating that table. Let's see if that solves our problem. Errors are my favorite thing because they tell me what I forgot. Oh, good. We didn't forget anything else. Ancient holder on the blockchain Elrond. Staking and unstaking means sending an asset to and receiving from a smart contract address. Yeah, this is a really simple version of staking. There is better ways to do staking. But in our case, all we really need to do is set it so that it's either on or off. I guess if you wanted to call it, on our contract we call it turning on and turning off. So we call it turning them on, and this just means that you gain access to certain abilities when your NFT is turned on. So you can turn on your miner, and then you start earning KDA. You can turn it off, and you can start listing it on the marketplace. And that's pretty much it there. But there's other more complex ways of doing staking. Yeah, it's just a toggle on and off. Do we want it to be mining or not? Yeah, there's a whole contract dedicated to staking that's called the Stake Factory. I know the Kadena's founder is using that, or he's developing that, and it's a lot more robust than what we're doing right now. Time 5:41. We're doing pretty good on time, as long as this actually submits. I just want to get to using this thing, you know? Ah, gas error. I guess it got too expensive. So let's raise this to 75,000. Get rid of a 0 there. We'll be broke pretty soon. Alright, we're getting there. So after this, we will stake the NFT. And then... Did I make that an integer? I'm just remembering. Thanks, crypto accountant, for the kind words. Yeah, ancient holders. So the staking is you can put it into a contract, and then that contract will like do things with the NFT for you. Um, that's how it generally works. If you're like actually, you would give it to a contract address. Um, but the way that we've opted to do it is we just set this capability so that once the miner is staked, like it has that variable that's set to true, then you can't do anything with it other than have it staked. It's just a simple toggle, but most of them you do send to an area. All right, so we've got our table created. So we've got these functions here. We'll refresh them by going back and forth. We've got a bunch more stuff now. I should have added more details here. But so get owner 1. Here's the owner of the person who owns token 1. Let's copy that just for because I'm going to need it. Let's try and stake and see what happens. See if I program this correctly. So I pasted in the address that owns the token. He owns token 1, and we will sign the transaction with his keys there. Incorrect number of arguments supplied. Oh, I didn't program it correctly. Failure owner. Stake. Ah. So I needed to give it the token ID. And the token ID. Well, let's deploy that again, and then we will do a little bit of programming. I'm setting that to false, correct? Yeah. I think I need to subtract 1 here. If I don't, people are going to lose a tiny amount of money. That's fine. We have to redeploy the whole thing, so we'll set back 75. Oh, wait. Oh, well. Was reading Twitch chat and just click submit without looking. Sorry, Kyle. Yeah, I tried to say them pretty early. I forgot to say the last one until like an hour and 10 minutes in. Ron has listed them in chat. The number 4, KMC, and life, but not in that order. Our friend is back. She's here to help us program. I guess I need some light in here. It's getting dark. Alright, so we've got our module hopefully fixed. Let's try staking. There's our address. Token ID is 1. Now I have to type around the dog. I didn't click the signy thing. And I get that again. No row found. Mind update count. So this means that I never added this to the accounts table, which means I forgot to initialize. So I did set it up, but we did enough programming that I forgot to initialize it. So we'll just deploy once again. This is costing us, like, if we were doing this on the mainnet, this is costing us 7 cents every time I make a mistake. So you'd be a bit more careful than this. There we go. Here, I'll give her a treat, and then she'll come back. While we're waiting. Come on. Up. Yeah, well, you can't see her, but she got a treat. There you go. Jad Inu coin? Not for a while. Who knows? We might be creating a coin. Jad Inu. We just started accepting Pepe coin for our ASICs on block mining. Oh boy. Oh, dog's back. Come on. There you go. We have retrieved the dog. I think she wants a treat. Good girl. Alright, module deployed. I think it's actually 10 million or 10 billion Pepe per miner. I forget what factor of 10 it is. But it's like a comical amount. Alright, let's hope that stake works now. Without actually doing any thinking and just letting the errors do the thinking for us. Okay, that means that we need to add another capability here. This is like the coin transfer, but we have to manually add it. So what is that called? What do I have it called? Pact intro KMC. Pact intro KMC dot account card. I'm typing around the dog again. Okay. So I will I'll paste this to be a bit more legible in just a moment. Because this box is entirely too small for its purpose. We don't need 75,000 there. Okay, so our function works. Let's delete a 5 from here and see what happens. Account is not the owner of the NFT. So that means that our owner function is working. This person who doesn't have a 5 on their K address tried to make it so that they would turn off this NFT, but our owner capability prevented them from doing that. So let's copy this thing so I can show you it, and then we'll submit, and that will stake the NFT. All right. This is what that looks like. So we have free.pact intro KMC. This is the module name, the account guard, and then what our account is. So it's just getting this capability down here. Did I set that correctly? Yes, I did. Owner. That's where, like, we wanted the owner capability, but because we're composing it, that means we wanted the account guard as well. So that is working. That means that the unstake should be working as well. Let's use our select function. I get tokens owned. Do we have this guy? Okay. 50,000. Cool. So now it's staked. We originally set it to false. Now it's true. ID 1. Hello, alkaline number. How you doing? So we have our ID staked here. Now we can start mining. We're gonna sort of do a really quick thing. We're gonna stop scrolling. Okay, good. So I pre-programmed this. It's going to update the KDA mind. Don't worry about all this code, but it will be available, like posted in that Excel document as like a little link. And this is what we're doing. So for as long as this thing functions, we are going to update the KDA mind. So we're going to be mining 0.3 KDA every minute. This is 60 seconds right there. And it's just going to wait 60 seconds and it's going to mine 0.03 again. So let's do that. Node insert KDA mind.js, and that should just kind of go. Rejected. Creation time is not defined. Perfect. Create account. This is a little dangerous for me to be doing this on this screen. Okay. I have secret keys on here. Creation time. Okay, I forgot a line of code. No problem. Line of code is back. We'll get rid of that. We got an error for some reason, so let's figure out why. Well, as you can tell, it's really hard to look at. Let's try response dot. I don't think I gave it the right capability. Nope, I didn't. Okay, let's just delete this so I can move on there. Oh, what's up, GP? Insert row found, so we'll get rid of initialize. Alright, so we're going to do that manually because I don't feel like doing this kind of coding on stream. I wasn't able to test it because I didn't have a contract deployed. So we'll just get rid of that requirement, and we'll slowly start mining KDA. So what's our requirements still? Buy multiple tokens. That's a good idea. Let's people buy a bunch at once. So this lets us buy a single one. Now let's do multiple. Buy token with an S. So we are going to do account string amount integer. We will move this to our old function here, or to our new one. Cool. Buy tokens. So they're going to pay the price times the amount, and then we are going to do what's basically a loop. This is a really funky thing about Pact, is you can't do, if you're familiar with for loops, they don't exist in this. So the only thing that exists for doing that kind of looping is a map. To do a map, you use this syntax. So you say map, and then I want to call the buy token function a bunch of times, and then you pass it a list. So in this case, I'm going to do make list amount. Cool. So what make list does, list, we can see over here, amount, let's say 5. Make list. What's the syntax for that? It's been a minute. Ah, true. Why is it true? Oh, right. You need like a thing to put in there. Duh. So this just makes a list of like a bunch of objects, and this is sort of my way of manipulating the map function. So if we wanted to call it 5 times, and we don't really need to pass anything into it, we would just do map by token, and then make list. So we're making 5 things if we want to buy 5 tokens, and the one is not relevant. Like it's just we can say true. I think that makes it a bit easier. So let's examine this function here. Buy token has a count, and then that's always going to be static. So that one's first, and then we need this second function amount integer, or boolean. Okay. Can I help you? Yep, no problem, Hank. So we will do multiple tokens here. That should work. We're just gonna buy the tokens, and because we're transferring coins, only the person who owns this wallet can actually call the contract. So we don't need to put any additional ones there. So let's see if that works. Now we should be able to buy multiple. So that's the map function. So what map is actually meant to do is, 1 second. What it's actually meant to do is you apply whatever that first variable is into all of the things in a list. So in this case, we have, I don't want to close this. Here, let's do this. Request key, paste. Okay. So you take this thing and you apply it to everything in the list. So this list is just a bunch of trues. It's like 5 trues. That's what it looks like. And you're calling the buy token function as many times as this list has objects. So in this case, it's going to go through. It's starting at 1, and then going to 2, 3, 4, 5, or whatever this token is. So it's getting called all those times. And this is sort of like a loop, how to do a loop in Pact. You can also use fold, which lets you add a bunch of things together. So if you have a whole list of things, you can add them. I think those are the 2 things that are really unusual. Like normally you would use a for loop or like a while loop for that. But fold and map you can use together. Did our thing finish? Yes. Okay. Let's try buying multiple tokens. We gotta refresh. Buy tokens. We need to get our address. 5. Yeah, so at doc, I'll show you in just a moment what that does. Alright. So right now our coin transfer is 2.5 because that's how much it costs for 5 tokens. So that's looking good. Cool. So now we have 5 successes. So we will have minted 5 NFTs. All right. So we will save that over here. And then go. One thing that I noticed, this is whenever somebody's minting, it's always being set to 1. I don't that doesn't matter for this contract, but it could matter where if when you stake something, you send Kadena like we do on the turn on function. We claim to an account every time that a miner is off, so that way it gets a lot of it starts to accumulate KDA in the Builders Club. So every time that we turn on a miner, that's how that's why a Kadena gets sent. But here it doesn't really matter because as soon as you stake it, it will get updated to the actual count. Okay, so that's good. We've got 5 tokens now. We can see that how many this guy owns. Let's see what it looks like when you can have more than 1. We've got our setter gas. So select is a very expensive function. You can see it costs 40,000 to do a select function. So these are only things that you ever want to use when you are calling them locally, like getting this raw response and not hitting submit. Otherwise, you're just like burning cash, and it fills an entire block, which is not ideal for anyone. So now we've set our gas to above 40,000, and it just goes up. But yeah, so we've got this is 1 token, ID 1 staked true, ID 2, ID 3, 4, 5, and 6, and staked is false for all those. So now we have 1 that's staked and 6 that are not. We can do the same thing for the defund stake multiple. Account string, token ID string, token ID list, actually. We're going to use a list now. This is where I think the map will make a bit more sense in this case. Map, stake, and we got to pass in the account. And then we're passing in all the token IDs. So we can just pass in token IDs, make that an S. And now we are passing in a list that looks like this. Let's show it off here. Let's just copy this. I guess I can't copy that? No, I can. So 2, 3, 4, 5, 6. So now we can stake multiple here. As soon as I can select it. There we go. So now I'm going to stake all of these. That is it. Yeah, that's it. Let's do this here. Unstake. Okay, that looks good. And then, what's wrong with this? I have this functioning up here, so it's working somehow. Is it actually wrong? We'll comment that out. And then see what happens. Okay, so that's functioning. Token IDs, let's see what happens. I could not tell you what was wrong with that. Is that it right there? I think it was that thing that was sitting there. Yep, it's in both. Whoops. There's that tiny little dot thing there. and I couldn't see it. Alright, so that's good. Let's update our tokens owned to include everything that's in there. So mind index. Okay. Thanks, Tiptoe. I'll see you later. Cool. That's good. Let's deploy that. And we need to increase our gas. Let's set it to 75,000. And we're loading the module. Alright. While that's going, let's mine some Kadena. Insert KDA mine. So we removed the inability to add it. So now any function can add this, or any account can add this. What did I name that? KDA mine. Okay, that should work. Okay, good. Set the gas again. Alright, so that should deploy. Whenever that deploys, we will have a functioning insert KDA mined. And then I think the final step here is going to be to get this this claim rewards thing going. So we'll do that. I think let's try and do it in like 10 minutes or something, so I'm not keeping you guys forever. So we have our KDA mine schema. What do we need for that? They need math, they need events, and how much they can claim. Okay. They need an account to claim from. That is the key. So we'll pull that from over here. And I will explain all of these things that we're adding. This is a contract controlled account right there. So we've completely covered capabilities. We've defined object types. We're using loops with map and fold. I didn't really go over fold that well. We've defined variables with let, and we've done functions. So I can explain let further, but let's get this done here. Okay. Perfect. So we've got these 4 functions here. There's a whole article on how to do this. I will add that to the important links here. So what we're going to do is we're going to deploy this. Let me just make sure it's all there. Yep. Okay. See, testnet is nice because you don't need to worry about spending money at all. You can just deploy as much as you want to make sure things work. Alright, let's insert some KDA mined. Let's give it 0.1. Did I not fix that? Oh, they don't have detail on testnet. Okay. I think I actually messed up this table because I guess I can just call it index, but it won't make sense. All right. So that should work there. I just named my variable wrong. Thanks, Alkaline. All right. So let's see if that previous one went through. Yeah. So we've got this function here. I will find that create simple user guard. Hold on. I can't immediately find it, so I will find that later. So we're going to create a simple user guard. We need a funder. The funder will just be whoever we want. The amount, we're just going to set it to 5.0 so we can have something to claim. And we're going to call this KMC Pact Intro Account. We don't need to call it KMC. Pact Intro Account. So we're going to fund it with 5 KDA. We're going to pretend that's how much we've mined. So that way people can claim it. Set this to 5,000 because the coin transfer is like 3,000 gas. We just add the capability. And then we can do this. So this will this will create and fund a new account. We can put that there while we wait. And then we can watch this new account. I think I called it Pact Intro Account. And we will add that. I put quotations around it. So we'll watch the account, Pact Intro Account. Okay, it does not exist yet, but as soon as this transaction goes through, it should have 5 KDA. And then we have a contract controlled account. Agent holder. How would you recommend building stuff on Kadena? Messing around with a web editor like I did, or using Pact and REPL files and running them locally with Pact installed? So you definitely want to do REPL files and running them locally. This is just like a really fast, no setup required kind of thing. If you're brand new to programming, it takes a little while to like get all of this set up, and then you're dealing with JavaScript to deploy things. So it's just a lot to go through. As you can tell, we've already been going for a while, and I haven't made it all that far. So it'd be a lot to go through all at once. But I plan on doing another teaching session with the REPL in the future. All right. So our Pact intro account here has 5 KDA. So that transaction went through. Go back to our contract, and let's make a claim function. Did we fix the KDA mine thing? Now we have 2 accounts listed here because that's what's listed in the accounts section. I see the issue. Okay. Well, I've made a mistake on that table, so we need to recreate it with a 2. Anyway, let's add a claim function while we're at it. So we have staking, we have buying. Let's add claim. This is where these capabilities are gonna like really come in to play. So we have an account string. We have token IDs list, and that's just going to be a list of like the 1, 2, 3, 4, 5, and then that should be good. I think it's going to be easier for me to just unclaim. Claim. Okay, we'll get all 3 of these. Okay, we can get rid of this middle one. That's special to our contract. But we have account guard. Recipient is going to be the person who owns the NFTs. We have private because we want claim work to only be called by private. And we have this new one called bank debit. When we created this account, we gave it a really unique guard. So if I can make this wide enough, I can't make it wide enough. But we gave it this user guard. You can see this one is pretty normal. It just says keys all. And that is our public key. So this is our keys here. If we could see the keys for this Pact intro account here, it would say it's a special type of guard, and it is a guard that does this. So only when we say with capability bank debit can we pull from this account. So if we add that to our claim function, we can then send KDA. So this coin transfer is taking it from Pact intro account and sending it to the recipient and calculating it. So we're using our let function here. This is creating a variable, and this is calculating how much a user has earned. We're going to get the total Kadena. This is actually going to get kind of complicated here, but I will explain it best I can. Get total earned. Okay. Is that calling enforced? Yep. We're adding a lot of code now. I should have anticipated this. All right. So the question was, why do you need with bank debit? If I didn't create this with the bank debit, then anybody would just be able to withdraw from this whenever they wanted. So you can only claim from that account, that Pact intro account, when this capability is in the function that you're calling from. And basically the way that I have it set up, this calculated number will operate exclusively on whether or not you are here's the math. It's operating exclusively on whether or not you are your NFTs are staked. If they are staked, then there's a lot of copying and pasting here. I'll go through that later. So if they are staked, then it will check how long they've been staked. So that's what your KDA index is for. And then after the KDA index, this one, is calculated, it will do a math on that. So for each NFT that you have, let's say you staked it at index 1, which holds, like the index is 1000 KDA. And then you have index 2, which is 1010 KDA. Index 50, which is 1250 KDA. Now, let's say you staked it here and claimed here. Sorry that it's moving. It's just a weird quirk of this editor. So let's say you staked here and you claimed here. Now, there's 1000 KDA starting, and your new value is 1250. So how much have you claimed in that amount of time? Well, 250 KDA is how much has been mined, but this 10,000 number is how many NFTs our old contract had. So we would have to do like get count, token count here. So Now it's dividing 1250 time, or so 250. We have 250 total. Divided by, there's a total of 6 NFTs equals some weird number. 250 divided by 6 is 41.6. So that's how much KDA you would have been able to claim. That's essentially how this would work if it was all set up for this contract. I'll make sure to finish this so it's set up for this contract, but I think I'm going to end it there. We can also create a claimed rewards thing. It would keep track of all the claimed rewards, and that can also be seen here, where we have a claim table. We have a claim count, just like before. We are just adding a count, and then we have a searchable list of all these claims. So you have your account in the schema, so that's whoever is claiming. You have your claim, which is however much is being calculated. So that would be your calculated value here. And then I have your block time just so we can see, for example, like this dashboard. You can see when you've claimed and how much you've claimed over time. So yeah, that's how that works. And what else? Where was I? There we go. Your claim count. This is just making everything go in order. You've claimed. Well, I guess this is the total number of claims that exist. So, if we actually check that on this, so we need to find get count on here. Claim count. Maybe. Yeah. So there's been 1,487 total claims since I fixed a bug about about 3 weeks ago. So that counter is new. There's been many more claims since September. But we were running into gas issues, and this was my solution to add a claim count. I guess I can fix this enforced thing here, and then we should be able to claim there. So we've got KDA mined index. I think that's what it's called in our token table, right? It's just called mined index. Let owner. So the owner is going to be get owner ID. Enforce. So we're enforcing the owner is equal to the account. So this is basically just using our miner owner function, but with less gas cost. The capability down here. It's doing this, but with a smaller gas cost. So let's go back to here. If it is, so this is a weird syntax that I'm not a fan of. This is an if statement. Let's take a look at this. Hey, thanks for listening, Slayer. I'm gonna be ending this very shortly. So this if statement here, I would need to create a new function that would check whether or not this is staked. So get staked ID. So now, if the ID is not staked, it will return 0. So that way it's just subtracting 1 from 1. And then if it's not staked, it earns no KDA. If it is staked, it does this mess. This mess isn't actually that bad. It is simply, it reads the KDA mined, the previous one. So the previous one was 1,250. And the previous one, latest one, yeah. So subtracting the latest KDA mined from the previous. So latest is 1250, and the previous is this guy here. So 1250 minus 1000 is 250, and then it's dividing 250 divided by 6, and that's how you figure out the calculated amount there. But yeah, that is pretty much our fully functional contract, but unfortunately I didn't make it fully functional. Ancient Holder, when uploading to the mainnet, the total gas cost depends on how many lines of code there are. Yes, but it's like really marginal. Like if I deploy this, it's not going to function because there's errors in the code right now. But like the maximum that anything can be, you can see if I try and set this to like a lot, it just defaults it to 150,000. If I had a 0 there, this is how I usually deploy it with how many zeros? 6 zeros. This is going to cost 1.5 KDA, so like 1 penny to deploy. And that's with like a massive file size. To deploy this behemoth, this is almost 1,500 lines of code, and it costs. This is 1,500 lines of code, and it costs 100,000 gas. So let's set this to 100,000. It costs 1 KDA to deploy, or 1.01 KDA, 1/100th. So it's literally a penny to deploy a contract that is like. This is the largest contract I've personally seen, and it's because I should have made it into multiple, but I've started doing that now. But yeah, this is the largest contract I've seen, and it costs like a penny. Okay. So I think that's where I'm going to end it for now. I will fully deploy this and make it functional for the claiming, and that will cover everything. I will upload this video to YouTube, and hopefully Twitch is saving the VOD, so that's available to everyone. But to everybody that tuned in and stayed, I really appreciate it, and I hope you guys learned at least something. And next time I will be showing everybody how to do REPL commands, which is like unit testing, and just a lot faster than deploying to the mainnet or testnet because it's instant. It gives you instant feedback. But thanks everybody for coming, and yeah, I hope to see y'all soon.